next. So if there is a type of feedback, or when there is a connection between the output and input, any connection is present between the output and input, then it is said to be the op amp is operating with feedback. Op amp is said to be operating in feedback, right? Whatever may be the connection, it may be direct connection, or it may be through some other circuit. If there is a connection exists between the output and input, then we used to say it is the device, whatever may be the device is said to be operating in feedback. Here we are considering the device as the op amp. So the operational amplifier is said to be operating in the feedback mode or closed loop mode. Feedback mode or closed loop configuration or closed loop mode, whatever it may be. So if there is exists some feedback between the output and input, or if there is some connection exists between the output and input, then it is said to be closed loop, or the device is said to be operating with feedback. It's said to be operating in feedback. So there are a lot of advantages when we use the feedback. So with feedback we can convert the open loop op amp circuit into closed loop configuration. With feedback we can convert the open loop op amp circuit into closed loop configuration. It has lot of advantages, we will see. So again, this closed loop feedback or this feedback are classified into two types: negative feedback and positive feedback. So whenever we are saying the device, any device is operating with feedback, so again we can classify that feedback into two types. One is the negative feedback, the other one is the positive feedback. When will we say it is operating in negative feedback? Means the feedback voltage that we are giving and input voltage that we are applying, if they are in phase reversal, or if there is a 180 degrees phase shift, 180 degrees phase shift between the feedback, Vf is nothing but the feedback voltage, and this is the input that we are applying. So if there is a 180 degrees phase shift, then that feedback is said to be negative feedback. Then such type of feedback is said to be negative feedback. Whereas in positive feedback, Vf and Vi are in phase, or whenever they are in phase, they are said to be in positive feedback, or the phase difference between these two is simply 0 degrees. So there is no phase difference, they are in phase. Whereas here they are out of phase, here they are out of phase. In negative feedback, the input voltage that we are applying and the output, from the output we are connecting to the input, so there is some portion of the output we are giving as an input to the circuit. So that voltage is called the feedback voltage. It may be voltage or it may be current. So whenever they are out of phase or 180 degrees phase shift exists between the feedback and the input, then they are said to be negative feedback. And if both are in phase, or there is no phase difference between the input and the feedback, then they are said to be positive feedback. So again, positive feedback has some application and negative feedback has some application, and positive feedback some advantage, negative feedback some advantage, and as well as their disadvantage. We will see this in the next slide. So negative feedback, what are the advantages of the negative feedback? So the first advantage is the gain is reduced. So with feedback, the gain is reduced. Or when compared to open loop, gain, the closed loop gain is low, or open loop gain is very high when compared to closed loop gain. So gain is reduced. So what is the advantage if gain is reduced? So if gain is reduced, so noise and any other type of disturbance will not get will not get amplified. So if gain is reduced, if gain is very high, so any sort of noise or any sort of disturbance or any type of interference will get amplified. So if it is gets amplified, the stability of the circuit will degrade. Stability of the circuit will degrade. So as gain is reduced, it stabilizes the gain. The noise and interference are will not get amplified. Will not get amplified. So with the gain is reduced, the system is more stable. The system is more stable when compared to open loop configuration, as well as positive feedback. Whereas in positive feedback, the gain will be increased. So there are a completely opposite in nature between negative feedback and positive feedback. Both are in opposite because of that 180 degrees phase shift or 180 degrees difference in case of negative feedback, whereas in phase in case of positive feedback. Gain will be reduced in negative feedback, whereas gain will be increased. So any sort of noise that is present will get amplified, will get amplified. So what is the disadvantage? System will become unstable. System will get unstable. So that is a disadvantage of the positive feedback. So the other advantage with the negative feedback, because as we have already seen, the gain bandwidth product is constant. So for any device, whether you are operating in open loop or closed loop or whatever is the mode, whether it is inverting or non-inverting amplifier, so the gain bandwidth product is always constant. Gain bandwidth product is always constant. So you see in negative feedback, the gain is reduced. Gain is reduced. So in order to make gain bandwidth product constant, the bandwidth will get improved. Bandwidth will get improved. Bandwidth is nothing but the range of frequencies. Range of frequencies over which you can operate the device. So more frequency range you can operate when you connect the op amp in the closed loop, that too again in negative feedback. That too again in negative feedback, the range of frequencies that you can operate the op amp will get increased. So the usefulness of the device is improved. Usefulness of the device, you can operate in more frequency bands. So that is the advantage of the negative feedback. Whereas in positive feedback, as gain is increased, so in order to make gain band product constant, so the bandwidth has to reduce. The bandwidth has to reduce. So you can operate only a narrow frequency range when you are operating the op amp in positive feedback. You can operate in only a narrow region. Narrow region. So we can see in further classes, the input resistance will increase and output resistance will be reduced. Input resistance, when we are operating the op amp in negative feedback, the input resistance will be increased and output resistance will be reduced. So this is more useful for the op amp, as the op amp is operate, or it will act as the, most of the cases it will act as the voltage amplifier. For voltage amplifier, the better characteristic that we required is input resistance should be as high as possible and output resistance should be as low as possible. That is a major characteristics for any voltage amplifier. For a voltage amplifier, the input resistance should be as high as possible and output resistance should be as low as possible. So these characteristics also will be improved when we operate the op amp in negative feedback. So here also there are changes that are occurred in input and output resistance, but that is not that much necessary. This next advantage, major advantage is noise effects. Noise effects like electrical and thermal noise will be reduced. Electrical and thermal noise will be reduced because the gain is decreasing. These all things are happening. Bandwidth increasing, stabilizing, and input resistances changes all are changing because the gain is reduced. So one major advantage of the negative feedback is the gain is reduced. Because the gain is reduced, all these things are happening. So the opposite are in positive feedback. The gain is increased, so the system will get unstable and bandwidth also gets decreased and noise effects also increases. So all these are happening because of the gain parameter. So that is the important difference between closed loop and open loop. And again, in negative feedback, the gain reduces. That is the major advantage of the any device when it is operating in negative feedback. So also, as the gain is reducing, the input offset voltage, the input effect of the input offset voltage at the output also decreases, right? So as we have seen, so because of the input offset voltage, we are getting some output voltage, unnecessary output voltage. Input offset voltage is the unnecessary voltage. Because of this, as the gain of the op amp is very high, it is also gets amplified. So because the gain is reduced, the effect of the input offset voltage at the output also is gets decreased. Whereas this is not the case. Simply in positive feedback, the effect of input offset voltage at the output will get increased, right? Next, so there is another important thing. So because of the temperature changes and supply voltage changes, so the parameters will get changed because we are using either BJT or MOSFETs inside the op amp. So BJT and MOSFET are temperature sensitive. So whenever temperature changes, beta changes. The gain of the circuit will change. Internal gain of the device, whether it may be BJT or MOSFET. So these are temperature dependent devices. So these parameters will change because of the negative feedback. So these effects also will be reduced. Will reduce, right? So what are the applications? So this feedback is used in amplifiers. We'll use it in amplifiers as well as non-linear circuits, etc. There are a lot of applications. When we use the op amp in negative feedback. Of course, in there, even though there are a lot of disadvantages when we use the op amp in positive feedback, but there are also certain applications when we use the op amp in positive feedback. So one major application where the device is useful when we are operating the op amp or any device in positive feedback means we can use this for generating the waveforms. By using this, we can generate the sine wave or triangular wave or sawtooth wave or square wave. We can generate any desired waveform whenever the device is operating in the positive feedback. And also we can use in comparator circuit. In comparator circuits also we will use the positive feedback. So these are the advantages of the negative feedback and these are the disadvantages of the positive feedback. Even though there are disadvantages, so in positive feedback also there are applications like oscillators and waveform generator and comparator circuit, right? So next we will see the types of feedback configuration. What are the different types of feedback configuration we have? Because whenever you are taking a device, so at the output you can sample either voltage or current. We have two parameters, right? Voltage and current. And this feedback are a part of the output. We need to connect again to the input. So at the input side, so at the output side, these two parameters, voltage and current, we can sample. And at the input side, we can connect either in series, or we can connect the in shunt with respect to input. The feedback sample. So whatever sample we are taking, whether it is maybe voltage sample or current sample, so this voltage or current sample with respect to input, we can connect either in series or shunt configuration. So this is at the input side. So at the input side, how we are connecting the part of the output, whether we are connecting in series or shunt, and at the output, which sample we are taking, the output the output, which sample we are taking. We are taking the voltage as a sample or current as a sample. So based on these two parameters, we are classified the feedback configuration. So we have at the input side in two ways we can connect. At the output side we can take two samples. So based on combining these two parameters, we have these four configuration. Voltage shunt. What is voltage shunt? So at the output side, so this always refers to the output and this always refers to the input side. So at the first configuration, so we are taking the voltage sample and that we are connecting in shunt. So then we'll get voltage shunt feedback. Second one, we are taking the voltage sample only, but we are connecting in series with the input. Then it is voltage series feedback. Next, now instead of voltage, we are taking the current sample. Output, we are taking the current sample. So again, that current, if we connect in shunt, then it is called current shunt feedback. And again, if we are connected in series with respect to the input, then it is called the current series feedback. Now we will look at one by one configuration. Now, the first configuration is voltage shunt feedback. Configuration. Or this is also inverting. In voltage shunt feedback configuration, whenever we connect the op amp, so it will act as the inverting amplifier. So we'll take the op amp. Right? We'll take the op amp. So at the op amp, if you are taking voltage sample, so how we need to take this voltage means in parallel only the voltages will be same. In series, the current will be same. In parallel, so whenever we are connecting two devices, or whenever we are connecting two elements, you see, so whatever voltage that we are connecting here, so whenever we connect the elements in parallel, so like this, two resistances R1, R2, so the voltage across R1 is also V in and across R2 is also V into. So the same principle we will use for sampling the output voltage. If we have to sample the voltage at the output, we have to take the sample in parallel. So for example, so here we have the output resistance. So here we need to take the output voltage as the sample. So this output sample we are connecting to the input through some feedback network. Some network has to present. So sometimes it may not be present. We may connect directly. So here we are assuming some feedback network is present. So for voltage sample, we have to take in parallel. With respect to the output, we have to connect in parallel, right? So from this terminal and from this terminal, we have connected in parallel. So a part of the output voltage we are giving as feedback. So the same voltage will appear here. Like this. You see, whenever we connect in parallel, so the top nodes are the top of the elements are connected at the same position, and the bottom of the other side also are connected at the same. So like this, we have connected the top side, we are connected to the same end, and the bottom ends also we have connected to the same end. So then we can sample the voltage. Now how we are giving in shunt? At the input we are giving in shunt. So at the input also we need to connect in shunt. At the input also we need to connect in shunt. With respect to the input voltage, we need to connect in shunt. shunt, right? So this is the shunt connection, right? This is the shunt connection. So here we'll have the in, the current due to the input voltage, and the op amp input also there will be some current, that is called the II. And here, because of this feedback network, because of this feedback network, there is some current that is flowing, that is called IF. So these configurations we are looking in the negative feedback. So why it is called negative feedback means, so for example at this node, at this node, at this node, at this node you apply KCL. You apply at a node we will apply KCL. In a loop we will apply KVL. Remember that. At a node we will apply KCL. So see this. So at this node, which currents are entering and which currents are leaving? IN is the only entering current, and IA and IF are leaving current. So according to the KCL, sum of the entering current, sum of the entering currents will be equal to the sum of the leaving current. So from this, what is the input current to the op amp? So it is IN minus IF. IN minus IF. You see the relationship between the input voltage and the feedback voltage. They are out of phase. They are not adding. They are opposing each other. They are opposing each other. So that's why all these configurations are in negative feedback. Why we are calling is negative feedback? Because the input whatever we are applying to the op amp, so you see the input voltage, the actual input voltage and the feedback voltage, they are opposing each other. They are not adding each other. So this is called voltage shunt, because at the output we are sampling the voltage. The output voltage we are giving to the feedback network. So at this we are getting some feedback voltage that with respect to the input we are connecting in shunt. So that is why it is called voltage shunt feedback configuration, or it is called inverting amplifier. We will see why it is called inverting amplifier again when we draw or when we replace the op amp with the actual schematic, op amp schematic. So this is called the voltage shunt feedback, because we are taking the sample at the output voltage and at the input we are connecting in shunt. Next. Yes. So whenever we connect the op amp in voltage series, it will operate in the non-inverting amplifier configuration. Non-inverting amplifier configuration. So we'll see the diagram. So again we'll take the op amp. Again we'll take the op amp, and again we'll consider the feedback network. Again we'll consider the feedback network. So this is the feedback network. So output we are taking voltage only, right? So that's why we need to take in parallel, because the output sample we need to take is voltage, right? So we need to connect in the same fashion. So how we connected voltage shunt? So here we'll get V0, and here we'll get feedback voltage, same polarity. So now at the input we need to connect in series with respect to the input, in series with respect to input, right? In series with respect to input, So this is the input voltage that we are applying. So in series we are connecting. So this is the input voltage plus minus, and op amp input, let us say the differential voltage is VD. Right? So in series with respect to the input we have connected. Again you apply KVL. Now you apply KVL in the input loop. So I am writing from the input voltage -2 plus V in, and here +2 minus VD. Again here +2 minus VF is equal to 0. Now what is VD? VD is equal to V in minus VF, Vin minus VF. So the differential voltage that we are applying to the op amp is nothing but the difference. They are the input voltage and the feedback voltage, they are opposing each other, or there is a 180 degrees phase reversal, right? So whenever we have minus, it is nothing but 180 degrees phase reversal. So that is why it is called in negative feedback. In negative feedback, they will oppose each other. The input, actual input, and the feedback, whatever it may be voltage or it may be current, they will oppose each other. Why it is called voltage series? At the output, we are taking a sample of the voltage, and that we are connecting in series with respect to the input voltage. So that is why it is called voltage series feedback configuration. Next, current shunt feedback configuration. Now the output sample that we need to take is the current. In series, the current is same. So whenever you want to sample the current, you need to connect the device in series. So we will consider this op amp and feedback network. Now at the output, we need to connect with respect to the feedback network, the relation or the connection from the output of the op amp to the input of the feedback network should be in series. Then only we can able to sample the current. The same current will give as an input to the feedback network. The same current will give to the feedback network. So at the input side, we have the shunt connection. At the input side, we'll have the shunt connection. At the input side, we'll have the shunt connection, right? So this is how we have to connect the current shunt. So this is the feedback current. This is the current that is flowing into the op amp, and this is the current that is due to the input voltage that we are applying. So whenever we have to sample the current, the connection between the output of the op amp and the feedback network should be, it is in series. So then only the same current will flow into the feedback network. So this at the input side, because it is shunt, we have to connect in this configuration. So current shunt feedback configuration will look like this. The next one is the current series feedback. So in current series feedback, the output is sample that we are going to take is current. So again we have to connect in series. At the input side, we need to connect in series. So that is the only difference in case of current series feedback configuration. So this is how the current series feedback will look like. At the input side, we need to connect in series. So V in, and this is VD, and this is VF, and this is the output current we will sample, and this is how the current series feedback configuration will look like. So in this way we can connect the op amp or any device in four configurations. So we have seen the op amp in open loop configuration and in closed loop configuration. In closed loop configuration also, you can operate the device in differential amplifier mode, inverting amplifier mode, and non-inverting amplifier mode. Whereas in open loop configuration also we can operate the device in differential amplifier mode, inverting amplifier mode and non-inverting amplifier mode. The major difference is whenever the device is operating in open loop, there is no any sort of connection between the output and input. So whenever the device is operating in closed loop, that means there is a connection between the output and input. There is a connection between the output and input. Again, the in closed loop operation we'll have two types of feedback. One is the positive feedback, the other one is a negative feedback. In negative feedback, there is a phase reversal relationship between the input voltage, the actual input voltage that is applied to the device. There is a phase reversal between the input voltage that we are applying and the feedback voltage, or it may be current or voltage. So there will be a phase reversal to the actual voltage that we are applying to the op amp. Right? So we'll stop.
If you like the video, please share, like and subscribe. Hit the bell icon to get latest video updates.